Hello, this is SMS and this is question number 6 of November 2024 paper 1. This question is from the chapter Binomial Expansion. So for the first part of this question, we need to show that a by root over of 4 plus bx is equivalent to a by 2 bracket 1 plus b by bx divided by 4 to the power negative half, where a and b are positive integers. So we need to show that this thing is equivalent to this. So let us write down the given expression, which is a by root over of 4 plus bx, right? Now this can be written as, we can't work with the square root like this, so if we write it in the power form, indices form, so this can be written as a plus bx to the power half, right? Now if you look at it, the power is negative here, so it's negative half, we got positive half, so we know that if we take this, the denominator, and multiply it with the numerator here, or just like break down the fraction here, then the polarity of the power will change. So this thing can also be written as a multiplied by, instead of dividing it, if I multiply it, then this would be 4 plus bx to the power negative half. The polarity of the power will change, or the indices will change. Here it was positive, now it will become negative, since I am changing division to multiplication here. Now, here, the next line, as you can see, this part of this expression is in the form of what I usually say is a plus bx to the power d, a plus bx to the power d, but since we already have a's and b's in the question, so let us just write it in this way. So this is actually in the form of the 4 plus bx to the power negative half is actually in the form of m plus nx to the power d, right? But here the m is not equals to 1, it is actually equals to, m is actually equals to 4. So the main thing we need to do here right now is make this make this 1. So the 4 we need to make it 1, because if you also look at the question here, there is a 1 here, and the bx, there is a 4 underneath it, and we can assume that they brought the 4 by actually taking this 4 common in order to make this part equivalent to 1. So the thing that we usually do for expanding this type of expression, when m, or what I usually write is a plus bx to the power d, when a is not equals to 1, we usually do it in this way. So when m plus nx to the power d, when m is not equals to 1, we bring the m out. So by bringing the m out at first, so we bring the m out, and now I write 1 plus nx to the power m by d, actually to the power whole d. Okay, the d is on top of the whole thing. Now what I did here is I factored the m out of this expression. So here the 1 is here, but if you just multiply it, m multiplied by 1 is m, and m multiplied by mx divided by m would be the m cancels out, and you actually get this, and to the power d. So this thing can also be further simplified and can be written as m to the power d multiplied by 1 plus nx by d, sorry, nx by m to the power d. Okay, so what I did is that I brought the power to this and to this because these are both getting multiplied. So m to the power 1 here, and this is 1. So if you multiply 1 multiply by d, then you will get d. So if I do the same thing for the given expression, we got the expression to be um, a multiplied by 4 plus bx to the power negative half. We will be working with just this part of the expression. A is a constant, so it won't be causing such a big effect, so we can just leave it as it is. So if I just write it like this, so A multiplied by, now if I take, in our case, m is equals to 4, m is equals to 4, n is equals to b, and d is equals to negative half. So if I do that thing here, so m to the power d, right? M to the power d, or at first I'm taking the m common, so I will take 4 common and write d on top of it. D is negative half, and bracket 1 plus nx divided by m. So 1 plus nx, so 1 plus n is b, so bx to the power m is 4, to the power, here we have a d here as well, so the d is negative half, so we just write negative half. So this is what we got here. If I write it here clearly, so 4 to the power negative half can also be written as 4 to the half. So I'm just taking this into a fraction, so this polarity will change. The same thing I did here. When I multiplied it, I changed the polarity of the power. Now I'm bringing it into a division form. This was 1 multiplied by 4 to the power half, negative half, and now if I divide it, the polarity will change. Bracket 1 plus bx to the divided by 4 to the power negative half. Now, if I further simplify this, an a multiplied by 4 to the power half is actually 1 by 2. Okay, it's like root over 4. Root over 4 is 1 by 2. Okay, it's 1 by 2. And then this would be 1 plus bx to the power 4 to the power 1 plus bx by 4 to the power negative half. And yeah. And we don't have to consider also here the negative portion when we do the root over thing here. Root over 4 is plus minus, will be plus minus 2, but we don't need to consider that because if you look at it, this is positive 4 here. So the root over the negative portion is actually not needed for most of these cases here. And also they have mentioned that a and b are positive integers, so we don't need that. So now we can multiply half here, so this is a continuation of this. So this would be if I multiply a multiplied by half and then 1 plus bx by 4 to the power negative half, then this can be further written as, okay, let me use the other bracket here. So this can be written as a by 2 bracket 1 plus bx by 4 to the power of this. And now if you look at it, they have access to show this, and we have actually showed that now. Now, for part B of this question, the expansion of this in ascending powers of x can be written as this p plus qx plus rx squared plus sx cubed, where these are all rational numbers. P, Q, R, S are actually coefficients. Okay, so what are coefficients? Coefficients are constants which are getting multiplied with the variable x squared, x cubed. Coefficients are constants like q, r, s. P is also a coefficient. P is a coefficient of x to the power 0. But we don't write x to the power 0 because x to the power 0 or anything to the power 0 is 1. So they have access to show that q is equivalent to negative a by b by 16, ab by 16, and s is equivalent to negative 5ab cubed by 2048. So we need to show that by expanding. At first we need to expand this a by this thing when we know that this is equivalent to this. So wait, yeah, now we know for part B we need to expand this a by b and this thing, and the expansion of or we can just say that if you want to expand this part, the way we do this is just a constant, you can just leave it as it is. So we expand it in this way. So when our expression is, for example, in this form of, for example, you can say that e plus fx to the power d, where e is equals to 1, you expand it in this way. So 1 plus d multiplied by fx plus d multiplied by d minus 1 divided by 2 multiplied by 1 multiplied by fx whole square plus d multiplied by d minus 1 multiplied by d minus 2 divided by 3 multiplied by 2 multiplied by 1 multiplied by fx to the power 3. Let's see the question again. They have access to expand till x to the power 3. So up until this is fine, because here we'll get x to the power 3. And a simple way to remember this formula, this format of expanding, is that at first we always start, the first term is 1, the second term will be the indices multiplied by the fx, or if I usually write it in a plus bx to the power d, so bx would be this, and then you keep on decreasing the d, and you keep on increasing the power of fx, so d would be d minus d multiplied by d minus 1, and there are two things in the numerator, so this is divided by 2 factorial, which is 2 multiplied by 1. There are three things in the fourth term, so d multiplied by d minus 1, d minus 2. The next term would be d multiplied by d minus 1 multiplied by d minus 2 multiplied by d minus 3. So the d will keep on decreasing and decreasing, divided by the number of terms in the top. So there are three terms, d minus 1, d minus 2, so that is 3 factorial which is 3 multiplied by 2 multiplied by 1, and the power of fx will keep on increasing. It is 1 here, 2 here, 3 here, and the next term it will be 4, and so on. So for the given expression, for our given expression, which is a by 2 1 plus bx to the power negative half, we will be just expanding this part. This part is just a constant, so we can just leave it in the front. So it is a by b. Now bracket 1 plus d is negative half by bx plus negative half by negative half minus 1 d multiplied by d minus 1 divided by 2 multiplied by 1, and bx squared, so b is, okay, now b is this, and then this is bx, this is bx to the power 4, so this would be, that's bx by 4, bx by 4, sorry, not to the power 4, and this would be bx by 4 whole square, plus the fourth term here, so which is d again, so negative half multiplied by negative half minus 1 multiplied by negative half minus 2 divided by 3 multiplied by 2 multiplied by 1 multiplied by bx multiplied by fx cube, so which is bx by 4 cube. Okay. So for our case, this was, I actually should have said this before. So E is 1, F is B by 4, X is X, and D is negative half. So now if I go down here, this would be A by 2 by 1 plus bx by 4 to the power negative half, and A by 2 1 minus bx by 8, and then if you put this in your calculator, negative half multiplied by negative half minus negative 1 divided by 2 multiplied by bx by 4 whole square, then this should be plus 3 by 128 b square x square minus negative half multiplied by negative half minus 1 multiplied by negative half minus 2 divided by 6 multiplied by bx by 4 whole cube. Then this would be 5 by 2048 b cube x cube. Okay, so b cube x cube. Now in the next line, by a by 2 1 plus bx by 4 to the power negative half, if I multiply the a by 2 with everything now, so this would be a by 2 multiplied by 1 is a by 2, negative a by 2 multiplied by bx by 8 is a bx by 16, plus a by 2 multiplied by 3 by 128 b square x square, so this is 3 multiplied by 2 5 6 a b square x square minus 5 by so this was, I took it a bit higher shape, so this would have been 1024, so this would be 2048 if I multiplied it 2, and this would be ab cube x cube. I actually saw the the next line in the slide that I'm seeing to actually see the calculations. So that the things get a bit quicker. I mistakenly saw the next line and wrote 2048 there. I'm sorry for that. So this would be this, and now they have access to write it in the form of, I think, p with um, uh, p plus qx plus rx squared plus x cubed. So p plus qx plus rx squared plus sx cubed. So here they have access to show that that q and r is equivalent to that. So the coefficient of x here is q and the coefficient of x here is negative a by b equals to 16. So we can write so equating this is also for a by 2 1 plus b x by 4 negative half. So equating the coefficient for x, so this is q is equals to negative a by ab multiplied by 16. The coefficient of r is the coefficient of x square is r here, and here it is 3 by 256 ab square. So that is 3 by 256 AB square. And for x cube, the coefficient is s, and here this is negative 5 by 2048 AB cube. So s is negative 5 by 2048 AB cube. Okay, so yeah, they have access, I think, to show just a and s, so this and this. Now for part c, given that q is equals to 128 by 5s and r is equals to 9 by 256, so 128 by 5s, so they have given q is 128 by 5s, and r is equals to 9 by 256. R is equivalent to 9 by 256. So now they have access to find the value to show that a and b, which are these values, so a and b are equivalent to these two values. So they have given q to be this, so q can be further expanded, so 128 by 5, and s is equivalent to negative 5 by 2048 ABQ. So q is equivalent to if you multiply, then this and this will get cancelled, and q would just be negative 1 by 16 AB cube. Okay, and now if we equate, we got q to be this here, and from the previous part we got q to be negative AB 16, so we can equate q, so which means q equals to q, so that is negative AB cube divided by 16 is equals to AB by 16. So negative. So the negative negatives will get cancelled. And the 16s will get cancelled. And here this would be B cubed by B equals to just 1. So this is become B cubed by B to the power 1. So it's 3 minus 1. The powers will get subtracted. So this is B squared by 1. And B would be plus minus root over of 1, which is equivalent to plus minus 1. But they have said they have said A and B are positive integers. So since A and B are positive integers, so B's the negative value is not possible. So just B would just be 1. And now they have also given us R to be 9 by 256, so 9 by 256, and from the previous expansion we got the coefficients of x square was r, and which was equivalent to 3 by 256 ab square. So then we got r to be 3 by 256 ab square, right? So now we equate r, do r equals to r. So this is 9 by 256 is equals to 3 by 256, sorry, 256 ab square. We know b is equals to 1. So we can just write 9 by 256 equals to 3 by 256 into a. And this 256 gets cancelled. Now we are left with 3a is equals to 9 and a is equals to 9 by 3, which is just 3. So we got the value of a to be 3 and b to be 1 as asked by the question. Now for part D and the last part. Hence, using an appropriate value of x, find 2 3 decimal places and approximate for the value of square root of 6 by 2. So for this type of question, or the questions from approximation in binomial expansion, where we have to at first find appropriate value of x at first, the value of x will have to be found through this expression because the x is here. And now if I write it, but this is with a and b, and we got the value of a to be 3 and b to be 1. So just simply if I write it here with a different color for some changes. So we were given a by root over of 4 plus bx there. Now we know a is 3 and root over b is just 1, so 4 plus x. So we need to find the value of x here using an appropriate value of x. To find the value of this, you can't just put this in your calculator and find the value, but you have to, the process is at first you have to make this look alike to this, for example, this. So if you see, we need to make this look like this. So if you see, wait, let me just write the 6 again. So here the root over is in the denominator, but here the root over is in the numerator. So what change do we have to do in this blue part is we have to rationalize it. So rationalize is actually dividing is multiplying, rationalizing, we have to multiply the numerator and the denominator by the root here. So the root is root over of 6 and root over of 6 here. We are rationalizing it, or you can just simply multiply this by root over of 6 and root over of 6, because at the end the roots cancel and you will be left with just root over of 6 by 2. So you can also assume it in that way. So we are doing this in order to bring a root in the denominator. So then this would be root over of 6 into, this is root over of 6 into 6 by 2 into root over of 6, which is root over 6 is 36, and root over of 36 is just 6 here. So this is 6 divided by 2 root 6, and then you just cancel this thing out, so you are left with 3 root 6. And now if you look at it, initially we had given that 3 by root over 4 plus x, and now the value, we need to find the value of this. So this is actually equivalent to 3 by root over of 6. So 3 by root over 6. So we can assume that these two are equal, because if you look at it, this is very similar. So we need to find the value of x for which this would be equal to this. So in order to be, we can just see that if x is equals to 2, then this will be root over of 6. But the proper way to do it is that by writing the value of x for which 3 by 4 plus x will be equal to 6. So then this would be just, so we can say that root over of, so just the roots will get cancelled, and this will be 6 minus 4 would be 2. So if x is equals to 2, then this will be 3 by root over of 6. So we know from the first part that we got expansion for this in the actually I think in the second part of the question. The expansion was this. Now I can substitute. Okay, so I can write this again here. So we know that 3 by 4 plus x is equals to a by 2 minus abx by 16 plus 3 by 256 ab square x square minus 5 by 2048 ab cube x cube. So then I can write it further. Here. So then this is 3ab square x square by 256 negative 5 by 2048 ab cube x cube. Okay, so we know x is equals to, and also the a and b, we know the value of them, and we know x is equals to 2, so this is just 3 by 6 equals to 3 by 2 minus 3, b is just 1, so we can ignore or write it here just, and x is just 2 here, we know, divided by 16 plus 3 multiplied by 3 multiplied by 1 square multiplied by 2 square divided by 256 minus 5 by 2048 is equivalent to A is, we know, 3 multiplied by 1 cube multiplied by 2 cube. So 3 by root over of 6 can be written as, if we put all this in the calculator, then you will get a value of 1207 to 3 decimal places, and this is actually equivalent to what they have asked for, 6 by root over 6 by 2. So that is it for this part of this question, and I hope you guys understood it. If you have any queries, leave down in the comments. Thank you.